What is a Cartesian product? Now, the last time you may have heard the word Cartesian was probably in algebra class when you encountered Cartesian coordinates. Named after French mathematician René Descartes, Cartesian coordinates describe every combination of x values paired with y values. For example, if the x-axis has 1, 2, 3, 4, and so on, and the y-axis has the same, the coordinates of a Cartesian coordinate grid would be captured by combining them like this. X-axis value and y-axis values 1, 1, 2, 1, 3, 1, 4, 1, followed by 1, 2, 2, 2, 3, 2, 4, 2, 1, 3, so on and so forth. Now, to keep this simple, let's go back to when we had each book associated with one author linked by a book FK in the author table. Now, swap out the x-axis values with these book entries. You imagine an ID column and a title column. ID 1, Dune. 3, Spring Data. 4, The Epic of Gilgamesh. And exchange the y-axis values with these author elements. ID, name, book foreign key. 1, Frank Herbert, 1. 2, Mark Pollack, 3. The Cartesian coordinates expansion would look a little like this. Book entry and author entry. 1, Dune. 1, Frank Herbert, 1. 3, Spring Data. 1, Frank Herbert, 1. 4, The Epic of Gilgamesh. 1, Frank Herbert, 1. Null, 1, Frank Herbert, 1. And then we'd have 1, Dune. 2, Mark Pollack, 3. 3, Spring Data. 2, Mark Pollack, 3. 4, The Epic of Gilgamesh. 2, Mark Pollack, 3. Null, 2, Mark Pollack, 3. And then 1, Dune, null. 3, Spring Data, null. 4, The Epic of Gilgamesh, null. And finally, just null and null. This is the Cartesian product. Now, in case you're confused about the entries with null, just think of them as the zero coordinate in relational databases. The point is that by combining every possible book with every possible author, we get a complete matrix of combinations. And that is what a join does before you apply the on clause. Now, you may have a hunch as to what the on clause does. If you guessed filtering out unmatched combinations of the Cartesian product, you go to the head of the class. If we were to write select book.title, author.name from book join author on book.id equals author book FK, we should expect this. Book entry, author entry. 1, Dune. 1, Frank Herbert, 1. 3, Spring Data. 2, Mark Pollack, 3. Now, to be clear, we would have the exact same pairs of values we saw before, and that's because we're joining the exact same tables with the exact same values. However, the on clause in the join causes the rows where the book.id, the furthest value on the left, and the author.bookfk, the furthest value to the right, don't match, and they get filtered out. And that's because this is an inner join, and the null rows are also cut. So earlier, when we had 12 rows, now we only have 2. Thus, 10 rows were filtered out. And this only joined 2 tables. In the video where we talked about a many-to-many relationship that involved 3 tables, we encounter the same thing. The only difference is that instead of a 2D matrix as shown above, imagine a 3D combination of values with each axis. For example, X, Y, and Z, mapping onto each table's values. The book table, the book author table, and the author table. This is where it's vital to point out that the database engine can actually rearrange the order it carries out our joins. It can choose to join either book with book author or book author with author first. The order doesn't matter. And there's a word that describes this property, Commutative. It's the same property that says 1 plus 2 equals 2 plus 1. And this is why every database engine on the planet invests huge resources in building optimizers that can analyze and figure out which join most efficiently produces the smallest results. The smaller the result of generating the Cartesian product and filtering non-matching rows, the faster the next join will be due to the reduced volume of rows that must be matched. This is also why we must understand when left outer join is needed and when it's not. When we perform a left outer join, we're pulling in more rows. To overuse it and then filter out later, perhaps in your application instead of inside the database engine, means you're wasting the database engine's ability to filter on your behalf. And database engines are great at filtering. The more you can push things onto the database, the better. Another way to phrase this is that database engines are great at filtering out rows of data because they're also great at deciding what to filter first.